Okay, practice exam for chapter 11. We'll go over each of these questions, walk you right through those. Okay, so the first question, the number of beans in the can is represented by the variable b. The expression that best represents the following diagram is, so again, these would be like the cups. So this would be 1 cup, 2 cup, 3 cup, 4 cup. Remember, the number of cups is the numerical coefficient. So there's 4b, and then it says plus, how many that is? 1, 2, 3, 4, 5, 6, 7, 8. So the one that matches that would be A. Number 2, the number of beans in a can represented by variable B, same thing, which expression represents that? So this time we have 3b, and it says subtract 6. 3b subtract 6, A. Number 3, which expression expresses 4 less than, so subtract 4, 5 times a number, where the number is represented by the letter n. 5 times the number is going to be 5n. So 4 less than this, so that has to be written as 5n subtract 4. So that would be D. So the common mistake there is to choose this one, going in order of the words. So you got to be careful with what it's saying. 4 less than, right? So if I chose A, that would be 5n less than 4. But this is 4 less than 5 times the number. Okay, number 4, which expression expresses 6 times a number, reduced by 3, subtract 3, where the number is represented by letter C. My bad. C. So 6C, so D. Solve the equation B plus 4 equals 16. Okay, so one-step operation. So I see the it's adding 4. So I subtract 4 to isolate my variable. Subtract 4. That leaves me with B equals 16 subtract 4 would be 12. C. Given the equation 5 plus, or m plus 5 equals 9, value, so solve this one. Opposite operation, subtract 5 from both sides. Isolates my variable, leaving it 9 minus 5 would be 4, so it would be A. 17 subtract C, solve the equation. 17 subtract C equals 12. Okay, so this one we can just do by inspection. 17 subtract something is 12, and that would be A, 5. Okay, 17 subtract something is 12. Yeah, it's 5. Okay, it isn't 7. 17 subtract 7 is 10. 17 subtract 19 would be negative 2. And 17 subtract 29 would be negative 12. 8. Given the equation G subtract 6 equals 9, what's the value of G? So again, one step again. So it's subtracting 6. So I do the opposite. So I add 6 plus 6. So G equals 9 plus 6 is 15. So that would be D. Okay. Okay, another one step here. B subtract 7 equals 15. So I'm subtracting 7, so I'm going to add 7 to cancel out that 7. I'm going to add 7 over on this side. So that leaves me with the B isolated. B equals 15 plus 7 is going to be 22. D. So again, if I'm checking that, I'm going fast here. I would do 22 subtract 7 equals 15. 22 subtract 7 is 15 equals 15. So check. Given the equation E subtract 4 equals 5, value of E. So again, I'm subtracting 4, so I'm going to add 4 plus 4. So E equals 9. So I'm saying 9 subtract 4 is 5. That's correct. So this one is C. Which equation describes a situation where a number represented by the variable n, so this is an unknown, so we've got n, is decreased by 7 to give an answer of 17? It looks to me like that would be C. The cost of an item is increased, so the cost is what we're not going to know, so the cost increased by $9. When the cost becomes $67. If the original cost of the item is original C, what's the description? C plus 9 equals 67, so that would be D. Solve for the value of the variable, so I'm going to solve this one. So 21 equals 3y. So here I have multiplication in this one step, so I divide to get rid of that multiplication. Divide by 3. Y is going to equal 7. So if I was to check that, I would say 21 equals 3 times 7. 3 times 7 is 21. So then that one's good. Okay, solve for p over 6 equals 4. So I have division on this one. So I'm going to multiply it by 6 to cancel that, times 6. So p equals 24. So we're saying that 24 divided by 6 equals 4. 24 divided by 6 is 4. So that one is correct. What's the value of 6 equals t over 6? Okay, so this one again, we're dividing by 6, so we're going to multiply by 6 times 6. So t equals 36. So we're saying 36 divided by 6 equals 6, which is correct. Okay, so that one is t equals 36, which is D. Solve for lots of these one-step ones. 9 times something equals 36. If I don't want to solve, if I just know this one, 9 times 4. Okay, doing that one by inspection. B. Okay, the number of candies represented by the variable C. If the candies are shared equally among 10 kids, so here's our candies, don't know what it is, shared equally among 10, so that's the number of candies divided by 10, because they're shared equally, that means division. Each child will get 8 candies, okay? How many candies does each child get if there's 2 fewer children, so this becomes 8. So first, let's just solve this and see what it is. Okay, so I'm dividing it by 10, so I'm going to multiply by 10. That gets rid of the 10. Times 10, so my C is going to equal 80. So we're saying there's 80 candies. So there's 80 candies, and now we're saying that there's 2 fewer children, so that means there's 8 children. So 80 divided by 8, 10. So each kid is now going to get 10 candies. So that one's C. Okay, so that means kind of got to walk through that one slowly. Hudson is 1/3 his father's age, and his father is 36. If Hudson's age is represented by the variable a, which equation describes this expression? So he's 1/3 of his father's. So you're going to divide his father's age by 3, and his father's is 36, so this one has to be C. Okay, his age is 1/3 of 36. So what's 36 divided by 3? So Hudson is 12. So in C. Which equation is represented here? So there's 3, 6, 9, 12, 15 equals 1 variable, 2 variables, so 2p plus 3. So that would be C. So again, the number of cups is the numerical coefficient. 2 cups, 2 times p. Okay, a 2-step here. So we've got 4s minus 4 equals 14. So I do reverse order of operations. So I'm going to get rid of the constant first. So I'm going to add 4 to cancel that, plus 4. Okay, so that gives me 4s equals 18. Oh my word. Looking back here, I'm like, wait. Yeah, I wrote the question down wrong. 4s minus 2 equals 14. So I'm going to add 2 plus 2. So I got 4s equals 16. So we got 4 times s, so I'm going to divide that by 4. Divide by 4. Now I got my variable all by himself, and that's 4. So I want to check and make sure I got this right. So I'm going to go 4 times 4, because I'm saying the s is 4. Subtract 2 equals 14. 4 times 4 is 16. Subtract 2 is 14. 14 equals 14. Check. So that one is s equals 4 is B. Okay, 3c plus 2 is 17. 3c plus 2 equals 17. So I subtract 2. 3c equals 15. Divide by 3. Divide by 3. I've got that variable isolated. 15 divided by 3 is 5. So I'm saying 5. So this means 3 times 5 plus 2 equals 17. So 3 times 5 is 15 plus 2 is 17. So it's a check. Okay, let me get some more room for myself here. So that one we're saying that C was 5. Okay, 2z subtract 2 equals 16. Again, we're subtracting 2, so I'm going to add 2 plus 2. Okay, so I've got 6z equals 18. Divide by 6. Z equals 3. So we're saying 6 times 3 minus 2 is 16. Okay, that's 18 minus 2 is 16. 16 equals 16. Okay, great. So it's 3 is my answer there. So that one would be A. Okay, solving another one, two-step equation, 8g minus 5 equals 43. So 8g minus 5 equals 43. I'm subtracting again, so I add 5 plus 5. So I've got 8g equals 48. Divide that by 8 because it's multiplying. Divide by 8, g equals 6. So I'm saying 8 times 6. Subtract 5 is 43. 8 times 6 is 48. Subtract 5 equals 43. 43 equals 43. Check. Okay. So then that one was 6. So it's B. Oops, B. All right. Janine has 6 more roses than, 6 more than. So that's 6 more than something. So it's going to be something plus 6. 6 more than twice the number of daffodils. So we don't know the number of daffodils. So twice the number of daffodils. So 6 more than those. She has 24 roses. Okay, so now I've got to solve this. Okay, so I'm going to subtract the 6, subtract 6. That gives me, I'll move over here, 2n equals 24 subtract 6 is 18. So you divide by 2, n equals 9. So we're saying she has 9 daffodils. So 9 times 2, so twice the number of daffodils is 18, and then 6 more is how many makes the number of roses. So she's got 18 daffodils, 24 roses. So then that would be, how many daffodils does she have? She has 9, B. Okay, next we have a model here that we're going to look after. So again, remember these are easy with the models. Okay, this means equal. It's a balance here. You see it's balanced. So this is the left side equals the right side. So on the right side, we have 4 times 5, so there's 20 over there. Okay, and there's plus 4 I see there. And then my x's, I have 1 variable, 2 variables, so that's 2 is my numerical coefficient. So I've got 2x plus 4 equals 20. And now it wants me to solve that. Subtract 4, 2x equals 16, divide by 2, okay, x equals 8. So I'm saying 8 boxes in each one of these. Okay, so that's what we're saying. So if I put 8 boxes in there, so I've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've got 20 on this side, 20 on this side. Okay, my check just to make sure, 2 times 8 plus 4 equals 20. 2 times 8 is 16 plus 4 equals 20. 20 equals 20. Check. This is great. Okay, last question. No, 2 left. Sorry, my bad. Equation modeling the total number of bald eagles in a valley is m plus f equals 27, where f represents the number of females, m represents the males. 27 is the total. If there are 13, so we've got m plus f equals 27. If there are 13 male eagles, solve the equations to see how many females there are. So males are represented by this, and now we've been told that there's 13, so I can take my m out and put a 13 in there. So now I've just got a one-step equation, 13 plus f equals 27. So how many are there? I can do this one by inspection and just look, 13 plus 14 is 27, or I can just do it with steps, subtract 13, f equals 14. Okay, so how many females? 14 females. Okay, use the following model. Okay, so cups again, those are the numerical coefficients. There's 3 of them, so it's 3n equals 12. There's 12 counters there. So solve it, divide by 3, n equals 4. So 3, my check here, 3 times 4 equals 12. 12 equals 12. Got her. Okay, that's the end of that practice video.